Rupa. Hi, Ruchi. Yes. Okay, so we have understood about valency. Actually, for valency, what I was doing is I was writing the valency of different type of atoms, and with the help of this valency part, I have exactly explained what and all things are there. Okay, so now okay, we were discussing about valency, and we were writing about the valency of different atomic numbers. So we reached till last part. We reached till one bit. I am sounding so much. See, we reached till valency. Yes. So we reached till valency oxidation number till where we have started hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Till neon we have reached. Now we are going to start with sodium. We are going to start with sodium. Okay. So sodium, sodium atomic number is sodium, magnesium. Okay, so sodium is Na, magnesium is Mg, sodium atomic number is 11, magnesium is 12. So in this, what we have done is, we started the atomic number and we started writing the outermost orbit. We know that atoms are exactly trying to gain the nearest noble gas configuration. So what is the meaning of nearest noble gas configuration? They want to gain stability. Stability is something which every atom of the periodic table wants to hold for. Okay. So every atom wants to acquire the nearest noble gas configuration. To attain the nearest noble gas configuration, actually what they are doing is C2A1. So what will be the atomic structure look like? The atomic structure look like this. So outermost orbit one electron will be there. Where outermost orbit one electron is there. So since outermost orbit one electron will be there, so these electron will be exactly see. So what sodium is wanting? Sodium is wanting to gain the nearest noble gas configuration. So once they will be wishing to gain the nearest noble gas configuration, what they will be doing is they will be releasing because we know that hydrogen, helium, lithium like this, if you will go, you will be landing towards neon. Neon will be like sodium, neon will be 2 and 8. So 100% it will be 2 and 8. So what is the valency of sodium? The valency of sodium is 1. Why? Because in the outermost orbit it is having one electron. So this one electron it is exactly going to lose. So once they will be losing this one electron, it will be exactly gaining the nearest noble gas configuration. So nearest noble gas configuration, it is exactly going to reach. Got it? So please kindly note down this one. Okay, Andy, what is electronic configuration? Electronic configuration is electronic configuration is like a lemon cells. Now, what is the amount of electron? What is the number of electron that is exactly present in different orbit that will become the electronic configuration? That will become the electronic configuration. That will become the electronic configuration. So now what we are going to do is we will be writing this part. So I hope you might have understood what is the meaning of electronic configuration. The meaning of electronic configuration is what is the capacity of electron in specific orbit. Understood? So that is exactly considered as electronic configuration, and according to that electronic configuration only, yes, electronic configuration only, the atoms are exactly present. So what we are going to understand here is what is the valency. Since the outermost orbit only one electron is there, outermost orbit only one electron is there. So in outermost orbit one electron is there, so its valency is 1. So now it wants to gain the nearest noble gas configuration of neon, because neon is the nearest noble gas. So since neon is the nearest noble gas, it will exactly try to give its one electron. So since it is going to give its one electron, what will happen? Yes, understood. So it is exactly going, yes, that's it. So it is exactly going to give its nearest noble gas configuration. So what we are going to do? We are going to remove this one electron. So that means what? Once it is having a capacity to lose its one electron, it will become electropositive. So sodium is going to give its one electron. So once it is going to give its one electron, it will become electropositive. Understood? So once the sodium atom is giving one electron, it will become sodium ion. Understood? Now it is exactly sodium ion is similar to that of neon. Got it? So neon is just like neon's outermost orbit is having 2 and 8 electrons. Neon outermost orbit is having 2 and 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So outermost orbit, how many electrons are there? 8 electrons are there. So outermost orbit it is having 8 electrons. So its configuration will become same as that of sodium ion. So sodium ion and neon resembles each other. Good evening, Himanshu. So sodium ion and neon resembles each other. Got it? So I hope you might have understood this part. Like whenever somebody will be talking about sodium, sodium is having outermost one electron. So definitely it is trying to release that one electron and gain the nearest noble gas configuration. And gain the nearest noble gas configuration. I hope you might have understood this one. So I hope you might have understood this one. So this is exactly clear. It is clear. Yes. Good evening. So then it is clear that which atom, see, they are exactly yes. So they are going to lose electron and become like that. Same is that of magnesium. Same is that of magnesium. In the case of magnesium, in the case of that of magnesium, magnesium is exactly having what 12. So once magnesium is having 12, it will become 2, 8, 2. So definitely its outermost orbit will have how many electrons? Its outermost orbit will have 12 electrons or 2 electrons. 2 electrons. See, first orbit 2 electrons, second orbit 1, 2, 3, 4, 5, 6, 7, 8, outermost orbit 2 electrons. So these 2 electrons they are going to lose. So these 2 electrons they are going to lose. Rupa, these 2 electrons they are going to lose. And once they are losing the 2 electrons, once they are losing the 2 electrons, hmm? So once they are losing 2 electrons, they will gain the nearest noble gas configuration. I hope you might have understood. So here, what you are going to do, Auntie, after this session, can you teach work and energy? Yes, I'm going to teach gravitation again one more time and work and energy also. So don't worry about it. I'll be teaching you. That don't worry. So here, it is 2 electrons will be exactly taken out. So magnesium is going to release 2 electrons. So once magnesium is going to release these 2 electrons, it is going to, if it is added then different, so magnesium will become Mg2 plus when it will be releasing 2 electrons. So definitely once it will release 2 electrons means outermost orbit, again these 2 electrons will vanish. Again it will gain the nearest local gas configuration of neon. So magnesium and sodium they will gain the nearest noble gas configuration of neon means first orbit 2 electrons, second orbit 8 electrons after releasing electrons. So how many electrons it is releasing? It is releasing, sodium is releasing 1 electron and magnesium is releasing 2 electrons. So you need to understand this one. After release of 1 electron and 2 electron, they are gaining the nearest noble gas configuration of neon. So they will become stable. So definitely stability is one of the most crucial factor for every atom to attain. Sir, times for every atom to attend. So I hope you might have understood. So if somebody will be asking you when they are attaining the nearest noble gas configuration, they are attaining the nearest noble gas configuration after exactly giving 1 electron or 2 electron. I hope you might have understood. So definitely 1 electron and 2 electron will be released. Understood? After gaining, once they are releasing this electron, they gain the nearest noble gas configuration and they become stable. So can you tell me atom is stable or ion is more stable? Sodium atom is stable or ion is more stable? Sodium atom is stable or ion is more stable? Atom is stable or ion is more stable? What is the correct answer? The correct answer is C. You need to understand that. Yes, auntie. I'm asking question from you. Atom is stable or ion is stable? See, once they gain the nearest noble gas configuration, they are supposed to be. That's what now. Sodium is highly reactive metal. It's very highly reactive. You keep in air now, it will boom. Understood? Yes. So sodium now it is very highly. So only sodium is not kept under water also, steam also. Any other situation, if you will keep sodium now, it will start bombarding. It will boom. Understood? So where sodium is kept? Sodium is kept under kerosene. Sodium and potassium are supposed to be very reactive. Yes. So sodium and potassium is supposed to be very, very reactive. So where they are kept? They are kept under kerosene. Where they are keeping under kerosene. I hope you might have understood. So since they are very, very reactive, so they are always kept under. Atom is reactive. Yes, sodium. Yeah, they can react in air also. They can react in water also. They can react in steam also. So any other situation, vapor also. So wherever you will be keeping sodium and potassium, they are supposed to be very, very reactive. They will react. Understood? They will start what you call burning. So definitely what they are going to be kept at, they are going to be kept in kerosene. Understood? So they are going to be kept under kerosene. So sodium is very reactive, very unstable. So how it is going to stabilize? By giving its one ion. The moment sodium will give its one ion and chlorine will take that ion, they will become stable and they are making salt, that is sodium chloride. I hope you might have understood. Sodium chloride formation, I hope everybody understood. So now magnesium also, MgCl, when we talk about magnesium, you need to see that magnesium will definitely be giving, magnesium is having two. So MgCl2 it is going to form. So when magnesium is losing two electrons. Chlorine outermost orbit, how many electron is there? Capacity is to take one. So chlorine will call one of its friend so that they will join together. Understood? Good evening. Okay, good evening. So definitely this is one of the most important crucial states where we can understand about sodium and magnesium. After sodium and magnesium comes aluminium. Okay. Now aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, iron, cobalt, nickel, copper, zinc. So till 30 it is over. So I hope but you for all the classes till standard 9, it is what is needed is we need to at least know about till 20. Understood? 20 atomic number. But 30 remembering is not at all a crime. It's actually good for you. Okay. So if you are knowing till 30 also, it is actually good for you. I hope you might have understood how and all to be getting. So next comes under that is aluminium. So if somebody will be asking you about aluminium, magnesium, so what? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. Chemical balancing also I'm going to teach. Just have patience. Okay. Sodium, magnesium, aluminium. So when you will be talking about aluminium, so that will be exactly coming as air. So what is the atomic number of aluminium? It is coming as 13. Understood? So 13 atomic number means, yes, auntie, somebody is late, auntie. Hmm? So here, that is first orbit, how many electrons will be there? 2. Second orbit, how many electrons will be there? Third orbit, how many electrons will be there? So first orbit, 1 and 2 electrons will be there. Second orbit, 1, 2, 3, 4, 5, 6, 7, 8. And third orbit, 3 electrons are there. So what is this valency? Valency is considered as combining capacity of an atom. Understood? How much it is exactly needing to combine. So definitely here, no late. Oh, you were there. Wow, super. So definitely combining capacity of an atom. So here combining capacity of an atom means here aluminium is going to release its 3 electron. So once aluminium is going to release its 3 electron, it will become stable. So aluminium is releasing what? Its 3 electrons and it will again gain the nearest noble gas configuration of neon. Understood? After that only we will talk about argon. E, ne, earth. Understood? Argon. So we are going to talk about argon afterwards. Hmm. So aluminium is 13. Stable gas here is neon. So one thing we have got here is sodium, magnesium, aluminium. Sodium, magnesium, aluminium. Just check, talk about sodium, magnesium, aluminium. Sodium, magnesium, aluminium, when you are talking about sodium, magnesium, aluminium. So here, neon. Neon, our valency is 0. Outermost orbit is what? Outermost orbit is 8 electrons. So it is stable. 2 and 8. Now next one is 2, 8, 1. So now sodium wants to become like neon. So it will shed off its 1 electron and it will become 2, 8. Now next magnesium 2, 8, 2. It will shed off its 2 electron and it will become like neon. Aluminium is 2, 8, 3. It will release its 3 electrons and it will become like neon. Understood? Everybody understood this part. So all wants to become like neon. Neon is the target for everyone because neon is stable. Neon is stable. So sodium will release how many electrons? 1. So its valency is 1. Magnesium is going to release how many electrons? 2 electrons. So its valency is 2. Understood? And aluminium is releasing how many electrons? 3 electrons. So what is its valency? Its valency is 3. So that's the most important point. I hope everybody understood this one and all wanted to get the nearest noble gas configuration. So once they are wishing to get the nearest noble gas configuration, the aluminium, after that comes silicon. So when somebody will be asking you about silicon, phosphorus, sulfur, chlorine, argon. So now we are going to talk about the other atomic numbers along their structure. So same period. Can you check here one thing? Check here. Look here. And Anish. So look here. When we are talking about silicon, it is 284. What is silicon is having? 284. Silicon is having how much? 284. So when we talk about silicon, it is having 284. So what can be the valency for silicon? So here 14. Atomic number is how much? 2 plus 8, 10. 10 plus 4, 40. So here it is coming as 14. So 14 means 2 and 8 means it is wanting to become like neon. Means it has to give this 4 electron in the outermost orbit. Understood? It has to give how many electrons? 4 electrons from the to the outermost orbit. How many electrons are there? 4 electrons. But it is not possible. They can't give this 4 electrons or they can't take 4 electrons. Neither they can give nor they can take. So silicon cannot give 4 electrons and cannot take 4 electrons. I hope you might have understood. Silicon cannot give 4 electrons and cannot take 4 electron also. So what silicon has to do? Silicon has to share. Silicon has to do what? Share. So silicon loves to share rather than giving or taking. How can it be possible? You understand one thing. I'm going to tell you one story. With the help of that story, you try to understand first. Okay. So our Tanisha is the school teacher. Now you are having a classroom. Okay, Tanisha, just understand it very nicely. Now you are having a classroom, Tanisha. In the first bench of your classroom, 2 idiots are there. So you are having 2 students in the first bench. Got it? Now, second bench you are having 8 students. 1, 2, 3, 4, 5, 6, 7, 8. Now, third bench you are having 4 more students. 1, 2, 3, 4. Now, because of this 2 and 8, you cannot be able to take care of this outer 4 electrons. Are you understanding? So, these 4 electrons are there or 4 students are there. It is called as shielding effect. What it is called as shielding effect. So exactly these electrons which are electrically neutral inside, stability is there. So they are very much satisfied by the nucleus. Understood? So this outer, they will shield the nucleus. So definitely the grip of the nucleus in this first and second orbit will be very high. Understood? So first and second orbit, this nucleus is nicely holding. But the outermost orbit, this 1, 2, 3 and 4 electrons are there. Their grip is quite loose. So what you did, you gave some energy and took this 1 electron. Nice. Understood? So some electron volt of energy you gave. Got it? Now this nucleus was balancing all the 14 electrons. But suddenly what happened? One went. So one went means the orbit will become quite smaller. Got it? So once the orbit will become quite smaller, the charge retained the same. Now, from nucleus, how much energy is coming to holding all this 14 electron? It is same only. Now, understood? But now it is holding how many electrons? 13. Now 13 is there because one went out. Got it? So since one is going out, now how many left in the outermost orbit? 13 with the same energy level. With the same energy level. Understood? Now what is happening? So now what is happening is कि now only 3 electrons are there in the outermost orbit. Got it? So the 3 electrons were present in the outermost orbit, and this is exactly one thing which is now the nucleus don't want to lose the 3 electrons. Correct now? So it will grip it. But this time I give extra energy and plug this one up. Understood? Extra more energy given, more bribe given, and I plug this one up. Got it? Now the nuclear charge will try to take the orbit more closer. Understood? So now the orbit is coming what more closer. Once the orbit is coming more closer, these two electrons nucleus, because nuclear power is same now. 1000 electron volt it was there, same 1000 electron volt it was putting for 14 electron. Now it is putting for how many electrons? 12 electrons. So 100% this time you have to give more drive, more energy to plug this electron. Are you understanding? The moment you are putting more energy to plug this electron, now this last one, the nucleus will exactly, now what will happen? The structure will become more smaller, and it will what? It will destabilize the atom, and the atom will collapse. Understood? Because from inside the nucleus, hey monkey, from inside the nucleus, same amount of energy is coming. Correct now? And it was having a capacity to hold how many electrons? 14. Now it is holding how many? 12. Now it is coming as a state of 11. So definitely it will not allow this one to go out. So structure will destabilize. Correct now? Now this is one case when the structure will destabilize and the structure will collapse. So now invitation given. So I can't give all four from the outermost orbit. Now second case is I can take four now. I can take 4. If I can't give means I can take 4. That possibility is there. So now let's check this one out. So if I am unable to give means I am going to take it. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, and then we have 1, 2, 3, 4. The moment I am taking one more here, what will happen? Now it is having a capacity to take care of how many electrons? 14 electrons. 115 member came. Till 15 it is okay, because now it is trying to distribute the energy to all 15. Now what will happen? Structure is smaller. Now one more you added. Now what will happen? Electron repulsion will start because orbit is small. Now again one more time you are going to add here. That means what? The repulsion force will become more higher. The structure will collapse. Understood? So here neither you can't take or now you can't give force. Understood? So that means there is only one possibility, and that is sharing. Here for valency 4, they are preferring to share rather than giving total 4 or taking 4. I hope you might have understood. So that is called as making covalent bond. The bond which is exactly made by sharing of electrons are considered as covalent bonding. So there are different type of bonding. I hope everybody understood. So there are different type of bonding. Ionic bond is there, metallic bond is there, covalent bond is there. Covalent bond is made by sharing because they have no other alternatives. I hope you might have understood. So some of the most prominent element which is exactly doing sharing, carbon is one of the more famous person I'm saying more famous element which is exactly sharing. I hope you might have understood. So this is exactly coming as one which is exactly going to share electrons. I hope you might have understood this part. So sharing is one of the most important section done by the element in the periodic table. I hope you might have got this point. So online children, did you understood what and all things are there? So here valency force. So silicon is having valency 4. So that means what? They are not going to make ionic bond. Rather than making ionic bond, what they are going to do? They will be sharing. And at the time of sharing, what type of bond they are going to make? Covalent bond. That's it. Understood? Silicon try to become like carbon, but it is not making carbon chain. Catenation is one of the unique property of carbon. So silicon also tries to become like carbon, but after 8 it is breaking. So self-linking property of carbon atom is called as catenation. So this catenation property means nobody is there means I can link myself. and make a very non-ending polymer. That's the property of carbon. Can I show you? So now look at carbon. It is just above silicon. That carbon atomic number is 2 and 4. Got it? So outermost orbit, how many electrons are there? 4 electrons are there. So in outermost orbit, if 4 electrons are there, what they will do? They neither can take 4 electron or give electron. I hope you might have understood. So neither they can take 4 electron or not they can give this 4 electron. So definitely what they will do? They will share. What they will do? They will share. So sharing part will be exactly done by, so 1, 2, 3, 4. So carbon will be sharing. So if carbon will not get anyone to share, what carbon will do? Carbon loves to form a non-ending bond. This is carbon, 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 carbon. This is exactly not possible for any other element in the periodic table. So this is actually not possible for any other element in the periodic table. It will keep on making this bonding. I hope you might have understood. Correct now. So this is exactly one of the biggest idea for making polymers. What they are making? Polymers. Understood? So medicine, what you are eating, carbohydrate, different type of carbohydrates are there now. Maltose, fructose, lactose, glucose, galactose. Understood not? Then cellulose, starch, sucrose, different type of carbohydrates are there. All different type of carbohydrates are long, so much. It is there. Okay. So much means what? Maltose, lactose, sucrose. Lactose is milk. Okay. Fruit is maltose, sucrose, lactose, glucose, galactose, starch, cellulose. This much happening. Okay. So that is carbohydrate, different type of carbohydrate. So that is your dress, what you are wearing is exactly long chain polymer. Carbon uncle is responsible for it. Understood? Nowadays, the bonnet of the vehicle also like aeroplane, they are making carbon structure. Why? Because it have the capacity to withstand that thunder. Electrostatic shielding is exactly given by carbon atoms in a very nice way. So you must learn many things. Okay. So definitely this is one of the most important factors. I hope you might have understood till here. I think I have removed everything. Nice. So here we have learned about magnesium. After magnesium we were talking sodium. So neon, sodium, magnesium. Understood now? So neon, sodium, magnesium, aluminium, silicon, phosphorus. So aluminium is exactly having outermost orbit 3 electrons. So it will give and become stable. Silicon 4. It will share. So valency is exactly how much? The valency is exactly coming as, okay. The exam valency is exactly coming as how much? 4. Now what about phosphorus? Phosphorus atomic number is 15. So first orbit, how many electrons? 2 electrons. Second orbit, how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. Third orbit, how many electrons? 5. 1, 2, 3, 4, 5. So 100% it want to gain the nearest noble gas configuration. So if it want to gain the nearest noble gas configuration, what it will do? It will take 3. Understood? Because this capacity of the orbit is exactly how much? 3. So once it will get 3, it will get stable. Got it? So what it will do? It will take 3 electrons. It will take 3 electrons. So once it is taking 3 electrons, so you know now there is one story. If we give, we are positive people because we are giving. But if we take, we become negative people. That time what we are becoming? Negative. So last class also I have discussed, I'm coming, I'm coming, I'm coming, I'm coming, I'm coming, I'm coming, I'm coming. Okay. So now look here. So definitely when you are giving, it is coming as positive. When you are taking, it is coming as negative. So if you give electron, like how sodium, magnesium, aluminium have done, it will become electropositive. But if you are taking like phosphorus, what you will become? Electronegative. What it will become? Electronegative. Understood? So electronegative means you are actually doing what? You are taking. Absolutely correct. So here, how phosphorus will take? Phosphorus want to gain. Now phosphorus is having a new target. Remember this one. Who is the target for phosphorus? Phosphorus is having a target argon. So phosphorus is very away from stable neon. Got it? So if phosphorus wants, phosphorus can't become like neon because it has to release how many electrons? 5 electrons, which is not possible. So what phosphorus will do? Who is the another stable element in presence of phosphorus? Argon. And argon is exactly how much? Argon is 288. Got it? So now phosphorus is very near to argon. If you check this one out, phosphorus is very near to argon. So phosphorus need how many electrons? 3 electrons. So once it will take this 3 electron, it will become like whom? It will become like argon. Got it? So phosphorus will take how many electrons? 3 electrons. It will become P3 minus. Understood? So phosphorus will take 3 electrons and it will become P3 minus. So phosphorus loves to take 3 electrons. Understood? Once it is taking 3 electrons, whom it will become like? Argon. And argon is stable. Understood? Phosphorus in its ground state is not stable. Got it? Because how much electrons it is needing? Right. 5 is there in the outermost orbit. Its valency is not 5. How much it is taking? So its valency is understood. So how much it is taking its valency? See, till 4 you giving 1, 2, 3. Valency is 1, 2, 3. 4 is shared. Valency is 4. But after 4, valency will again drop down to 3, 2, 1. Because first is give, then share, and then take. Understood? Give, share, take. Let's talk about this. Give, share, and take. So after phosphorus comes who? Sulfur. Sulfur. Sulfur is exactly 286. Now outermost orbit, how many electrons are there? 6. So how much it is needing? 2 to become like argon. See, argon is having 8. Sulfur is having 6. How much extra it is needing? 2. So its valency will become 2. It is electropositive or electronegative? Electronegative because it is taking 2 electrons. After sulfur comes chlorine. Chlorine is having 2, 8, 7. How much it is needing? 1 more. So its valency is 1. After that, it is 288. What is the valency? 0. What is the valency? 0. So all of them are electronegative and all of them here is electropositive. So let's understand the symmetry till first argon. Got it? In the periodic table, now we will do a final analyzation to understand the symmetry. Understood? So now we'll do a very nice chart. On our own, we are going to make chart to understand the entire content. Hydrogen, helium. This is coming as 1 electron it is there and here it is having how many electrons? 2 electrons. So definitely what is the valency of hydrogen? The valency of hydrogen is 1. The valency of helium is 0 because in its outermost orbit it is totally satisfied. So hydrogen I am keeping a little apart. So now hydrogen valency is 1. Now comes helium valency is 0. Hydrogen, helium. Now lithium, beryllium, boron. After that carbon, nitrogen, oxygen, fluorine, neon. Now listen. Here it is valency 1, 2, 3, 4, 3, 2, 1, 0. I am talking only about valency. So these three are electropositive because it is giving. This one is right, share. Understood? And this one is taking. So this will become what? Electro positive. After giving, what you will become? Positive. And this one is electro negative. So that means electropositivity reduces, electronegativity increases. Understood? Next comes, so now next comes again lithium, neon, after that sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. So definitely valency again here 1, 2, 3, 4, 3, 2, 1, 0. Understood? So again they will do what? Give valency. Understood? And here it is share. And this one is take. And they don't do anything. Valency. Did you understood the entire story of valency, please? Is this the most easiest way to understand valency? Yes, the combining capacity of an atom. Now you understood. So here valency will be for plus, for giving valency is 1, 2, 3. Here taking valency is 1, 2, 3. I hope you might have understood, children. Now tell me, is it easy to analyze? Huh? Huh? Because KLM cell you have to fill now beta. So if you are filling KLM cell, you need that chart. You just carry forward in that chart. Okay? You just carry forward in that chart. You write down that part. Understood it nicely, huh? So it comes under argon. Then comes potassium and calcium. So potassium and calcium. What will be potassium and calcium beta? Potassium, K, and calcium. What can be the valency of potassium and calcium? Again, valency 1 and got it? Sodium, potassium, calcium. So again, valency will be again. After that, again, if I will do that, I'll say the story: sodium, potassium, calcium, scandium, vanadium, chromium, manganese. Sorry, argon, potassium, calcium, vanadium, chromium, and cobalt, nickel, copper, zinc. So till 30 it will be against, but that is D block. It is going to penultimate cell. That's a different story. I'm not going to go there. Penultimate and anti-penultimate cells. That's a different story of carbon and what do you call it? That element. That way we are going to understand differently. Okay. After giving 2 electrons in the outermost orbit, again it will jump and fill 10 electrons. So here we will just do calcium, sorry, potassium. Potassium is 2, 8, 8, 1. It is not 9. Understood? So after filling 8 electrons in the outermost orbit, it will go again the fourth orbit and fill 1 electron. Since the capacity of third orbit is 18 electron, but then too they will not fill 18 electron. First they will go to outermost orbit, they will fill 1 electron and then they will come back. So here it is coming as 2881. And then calcium, it will become 2882. So outermost orbit, how many electrons will be there? 2 electrons. So what they will do? They will release this 1 electron and they will release this 2 electron to become like whom? Argon. Understood? So who is the role model for them? Argon is the role model for them. So that's the most crucial factor about atomic structure. So if anybody wants to understand atomic structure, you just listen this one carefully. You will be able to understand what is the meaning of valency, how valency. I'll call you. Wait. Today I'm going to call you. Just understand. Wait, wait. So definitely valency is exactly coming like that. Hmm. Argon. They want to gain the nearest noble gas configuration of whom? They want to gain the nearest noble gas configuration of argon. I hope you might have understood this part. So all of you understood this content. Argon. Yes, they want to gain the nearest noble gas configuration of argon. That's it. Yes, was it easy, difficult, or easy? So that's what is the story of valency. The story of valency looks difficult, but it is easy. You need to understand in your own way. See, in books they have written, in books they have written their own way. We have understood in our own way. Okay, so there is always a way to present everything. Now we are going to talk about chemical formula. You need to understand that every combination of element makes compound or atoms. Understood or not? So these combinations are exactly very important. You need to understand this part. So if somebody will be asking you this, what is chemical formula? Then what and all things you are going to talk about. So writing chemical formula or molecular compound is very difficult task. No, it is one important task we need to first understand. Okay. Thank you so much, Ruchi. So definitely, first we need to have to understand. Till ninth, if we have to teach means the student has to understand that valency is what. Now you understood that beta? Maximum valency is oil. 4. In 4, what they are doing? After that, they are again taking. First, 1, 2, 3 give, 4 share, and then they again till 0. And stable gas is exactly coming as 0. Stable gases will have what beta? Valency as 0. So now we'll talk about stoichiometric formula and molecular formula. Now you need to understand that when somebody will ask you, yes, so when somebody will ask you this one simple question, that why there is a need of making chemical compound, then you say that chemical compound, yes, can you tell me your name? I'll be able to say you. Yes, in Trikul my class is there. I'll be reaching there. Maths class is there. 100% maths class is there. Maha, 100% maths class is there. As I promised, tomorrow is marathon and you have to go with marathon for 3 chapters. So everything we have already aligned. See, after this class, I'm going there. 12th class is there. After 12th class, I'm having 10th class with people. So ma'am will post timing. Ma'am will post timing like that. Okay. I hope you might have understood this one. So now let's go for the next one. Now understand what is the meaning of chemical compound. See, we know that most of the element they can't exist in free state. Right now, just to understand now, can they be able to exist in free state? The answer is no. They love to combine and become stable. So they can combine with one or they can combine with more than one. Like if I'm going to talk about this one, so if they are exactly going to combine, so look here, sodium combining with chlorine. So that means what? One element combined with another element. So they combine with how many beta? They combine with two elements combined. But it's not the case always. You might have seen sulfuric acid H2SO4. How many elements are involved in combination and making a compound? Atoms are exactly 7. 4 to 6 plus 1, 7. But how many elements are involved in that? 3 elements are involved. And what and all are the elements that is involved? Hydrogen, sulfur and oxygen. Are you understanding? So if somebody will talk about glucose, then what answer? C6H12O6. So definitely for glucose, how many elements are combined here? Elements combined here. 3. Carbon, hydrogen, oxygen. Now talk about their atoms. 6 plus 6, 12, 12 plus 12, 24. Understood? So that is total atom. Atomicity is 24. Atomicity means number of atoms present in a compound or molecule. Number of atoms present in a compound or molecule will become its atomicity, and atomicity is 24. How many atoms are present here? 24. How many atoms are present here? 2. How many atoms are present here? 7. 4 plus 2, 6 plus 1, 7. How many elements are there? 3 elements are there. Are you understanding? So that becomes the atomicity, that becomes the understood. So compound will be made with 2, 3, 4 different type of how many elements? Maximum 3 or 4 elements will be combining together. KMnO4. Potassium permanganate. KMnO4. How many elements are there? How many elements are there? 3 elements are there. How much atoms are present there? 6. Now you are understanding? That means this is exactly compound. And if somebody will say that only one single compound will be there, then it is called as molecule. It is called as the simplest form of a compound is called as molecule. But like this, thousands are present. Then what we are going to call it as compound, because all of them are together. So when together will be there, they are called as compound. Like KMNO4, 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 KMNO4. So entire content is made with KMNO4. Then it will be called as compound. But one single unit will be there, means what it is called as molecule. What one single unit will be present here is called as molecule. But when many will be present there, they will be called as compound. Then did you understood without definition what is the difference between compound and a molecule? Molecule means one unit. And when total will be present there, they will be called as what? Compound. So that's the entire simple story to understand there. I hope you might have understood, all the children understood this one. What is the difference between compound and molecule? Got it? So in simple way, yes, absolutely. So definitely when somebody will be asking you, I think you people are ready to answer the questions in your own formative way. Did you understood? So molecular formula. The formula of a molecule where elements are presented, that will be called as molecular formula. A shorthand notation of a molecule in terms of symbols of various elements present is called as molecular formula. So what we were doing? We were wasting our time. No, the shorthand notation of molecule like NaCl. We didn't wrote name. We wrote NaCl. That is a molecular formula. Understood? Now H2O. What is that? Molecular formula. H2O2. What is that? Molecular formula. NaCl. What is that? Molecular formula. I hope you might have understood more than one molecule combined together, they are making compound. That's correct only. So that's one single unit when the CO2 is also molecular formula. Understood? So whenever somebody will be asking you, and plainly answer those questions. Why we need a very specific content? We will play with chemistry and we will answer like that. Understood now? So beta, what is molecular formula? Then you will represent element in their combined form like this symbolic presentation. It is called as molecular formula. What it is considered as beta? Molecular formula. I hope everybody understood this one. Now called as empirical formula. Empirical formula means of a substance is the simplest formula which gives the simplest whole number ratio between the number of atoms different element will be there. So this is exactly considered as empirical formula. So molecular formula and empirical formula means it will be balanced formula. Got it? So I can say that which molecule part will be there. So this is considered as empirical. So empirical formula is CH. This is molecular formula. This is what? Molecular formula. Now what is the ratio? 6 is to 12 is to 6. After cancelling, 1 is to 2 is to 1. So this will be considered as what? Empirical formula. What it is considered as? Empirical formula. Got it? So simplest presentation of a compound will be coming as empirical formula. Understood? The rules that you have to follow while writing a chemical formulas. So how to write a chemical formula? Did you understood what is the difference between empirical formula and molecular formula? Just do it one more time so that you will understand in a more exclusive way. So now look here. If somebody will be writing that H2SO4, so 2 is to 1 is to 4. There is no other way to cancel it. So this will become molecular formula also. The simplest whole number ratio will become the empirical. So your molecular formula and empirical formula both are same. But when hydrogen peroxide you are writing H2 and O2. So this becomes the molecular formula. Ratio is 2 is to 2. Cancel, it is coming as 1 is to 1. So empirical formula will become HO. Understood? Because 2 is to 2. So 1 is to 1 can cancel. The simplest formula is coming as H and O. So this becomes the empirical formula. This is the molecular formula. Is it easy to understand? Easy to understand? So for glucose, what is the molecular formula? C6H12O6. What is the empirical formula? CH2O will become the empirical formula. Is it understandable for everybody? So this is the difference between molecular formula and empirical formula. I am taking time to teach, but I will not be teaching here and there. I'll be teaching the best important part. Now, did you understood? If you will see the video again, the content will become very clear to you. That's my promise. Correct, no? If you will see the video again, you will be understanding everything. So, beta calcium oxide. Here, both sodium chloride and all these are exactly there. Here, chemical formula and molecular formula are all same. Understood, now? So now we have understood the valency charges of ion must be balanced. Valency and charges of ion must be balanced. This is one of the most important rule. It is one of the most important rule we have. So now we will be going for nomenclature. What is the meaning of nomenclature? So nomenclature of molecular formula that we are going to understand in next part, but we are going to nomenclature is not that much, but atom its prefix. Like this one you note down. If atom is there, atoms, one atom means mono, 2 means di, 3 means tri, 4 means tetra, 5 means penta. Understood? So if one atom is there means monoatomic, 2 atom is there means diatomic, 3 atom is there means triatomic, 4 atom is there means tetraatomic, and 5 atom is there means pentaatomic. 6 atom means after that hexaatomic or polyatomic. After that only one oxygen is there. Carbon monoxide. Why it is considered as carbon monoxide? Because only one atom is there. This is only one atom is there. One atom of oxygen is there. So what it is considered as? Carbon monoxide. What it is considered as, beta? Carbon monoxide. Here how many chlorine is there? 3. So what you are writing? Right. Specifically for electronegative part we are writing. Understood? So how many chlorine is there? So what you are writing? Penta. How many oxygen is there? Di. How many chlorine is there? What you are writing? Can I underline it so that you can understand? Specifically, we are writing the electronegative part. This is electropositive part. This is electronegative part. So in electronegative, how many oxygen is there? 1. So what word you have used? Mono. Electronegative part, how many elements are there? 3. So what you are using? Right. Here, penta. Here, di. Here, tetra. Did you got this point? Did you got this point? So this is exactly one of the breaking part where you are understanding the content to this limit. I hope everybody understood this contents now. This is one of the most important sections of molecular part, molecular or chemical reactions. You need to understand. Live is breaking now also. Is it breaking? Check, beta, is the live breaking? It's going to be 1 hour. I have to go for another coaching. I'm going triple Kundram. More 2 minutes class is left, so I'm going to finish it up. So definitely what is there? 1 oxygen there means what? Mono. 2 di. 3 tri. 4 tetra. 5 penta. I hope you might have understood the matter. So now these are called as prefix. Prefix means which comes first. Understood? The prefix meaning is the one which is coming first is considered as prefix. The one which will come after is called as suffix. Prefix and suffix, I hope you might have understood. Yes. So the one which is, I hope, how was the class today? Was it fruitful? Did you learn it nicely? When we talk about valency, valency is the combining capacity of an atom. Understood? And most of the element in the periodic table, what they want to gain the nearest noble gas configuration. If you will understand this part, means you will be able to answer. So next class we are going to start with examples, and then we will be going for naming of ionic. So naming of ionic compound crisscross rule is one of the major section of chemistry. Understood? And I will teach it very thoroughly so that you will not do mistake in all these sections. In 11th, you will be sitting and teaching other people. Hey, this will be like this. So definitely all this one crisscross rule are materials we are going to understand it very cleverly. I hope you might have understood this one. Bye for now, everyone.